All right, I'm going to show you some practice runs of how to do the final quiz that's due since I missed the Monday. So this is essentially this is it. This is your single step reactions one. And so what you'll see then is some sort of reaction that's occurring here, and you'll have this space in the bottom. What we're looking to do then is try to create the major product, and then the answer that goes in here is going to be the IUPAC name for this. So the first thing we do is we start out with this. So this is an organic compound. We're trying to figure out what the functional group is. There's really no functional group on this. So this is just an alkane. So we're looking for reactions of alkanes. And really this is the very first page on the PowerPoint slide that we've got. So if we go to the PowerPoint slide, we'll take a look here. Reactions of alkanes, free radical halogenation. And if we zoom in, what this is trying to tell us here is that if I have a carbon, so that's where this R is, and a hydrogen, and I have something like chlorine, bromine, or iodine with heat or light, in our case I think it's light, then it's going to replace the hydrogen with this chlorine or bromine or iodine. So the example here is they have a hydrogen here that's sticking off the carbon. Just note that it could be any one of these hydrogens. This is just one of the options. They're going to use bromine in this case, and so bromine gets replaced here. If we had to use chlorine, chlorine would get replaced here. And if it was iodine, iodine would get replaced here. And note that under a free radical reaction, any one of these can be the answer, okay? And so what I've done in the test and the quiz there is that I've provided multiple answers. So as long as you write the IUPAC name correctly, you'll get the right answer. So if we go back here then, what we're looking to do is to try to figure out what this answer is going to be. So if we take a look then at our molecule being reacted, we saw that one hydrogen is going to be replaced by a chlorine in this case, or if it was a bromine molecule. And so if I put these hydrogens, there's hydrogens all over this, so any one of them can be reacted with. But it just showed one reacting. So the product that would happen then is any one of these hydrogens, I'll pick this one here, and it's going to be replaced with a chlorine like this. And that's the final answer. I don't need to show the rest of the hydrogens because it doesn't matter for the actual for the answer. What matters is the answer is the name of this molecule. And so it's a cyclopentane, and in the one position here is a chloro. So it's a 1-chlorocyclopentane or a chlorocyclopentane. Either of those should be acceptable answers, and that is the answer that we'll type in. So going back to the quiz then, I'm going to type in 1-chloropentane. And just notice though, I've got no spaces. I'm doing proper IUPAC naming. So I've got a 1-chloropentane, no space. I've got the dash here. It is not a comma. If I were to use a comma, that would be incorrect. If I were to do an extra space here like this, that is incorrect. This program will not differentiate anything like that. But the main correct answer is this one here. If you did any other version of it, potentially it will be a wrong answer. So let's try another one here. So what we've got is an organic molecule again. We've got something that's reacting it. This is actually in 2 steps, above and below the arrow. But that doesn't matter. What we need to do is figure out what is the functional group here and what is it that's reacting with it so we can figure out what's going on. It's an alkene. It's on the reaction side, so this is a reaction of an alkene. So let's go try to find out what this could be. So when I scroll through and get to reactions of alkenes, I find very similar reactions going on here. There's one specifically with a cyclohexane, something similar. But there we go. There's an example right here that has this very similar sort of reaction going on. I have a cyclohexene, and it even tells us the answer here. But I'm going to create this diol. So I'm going to create 2 alcohols across the double bond. So that's essentially the reaction that's going to occur. Now note that we don't use trans in IUPAC, so don't include trans or cis in this. All the answer would be in this case would be cyclohexane 1,2-diol or 1,2-cyclohexane diol. So let's go and answer this question. So this is not a hexane, this is a pentane. So I have a cyclopentane, and we're going to name this. I have a dash after between the letter and the number, and then a comma between the numbers, and then now finally the answer. So it's either going to be a cyclopentane 1,2-diol or a 1,2-cyclopentane diol. Submit that, and I would be done. So for this one, we have two organic molecules, and there's nothing above or below the arrow. So on one of them here, we recognize this is an alkane with a halide on it. So this is an alkyl halide. So it's a reaction of an alkyl halide. Or we recognize over here that this is an alkyne. So it's a reaction of an alkyne or a reaction of a alkyl halide. So when we go look these up, we'll see what potential answer might be. So under reactions of alkyl halides, there's a big generic list of all the different things that can happen. Here's an alkyl halide. This is the carbon attached to either chlorine, bromine, or iodine, and I'm going to react it with something here. So note that everything here has got a negative charge on it. It's a nucleophile, as it's called. And if we go down the list here, we'll see a couple that have triple bonds in them. There's one right there with an alkyne. So there it is. There's a reaction with an alkyne, and ultimately we're going to create an alkyne, and the alkyl halide is going to disappear. So these carbons that are part of the alkyl halide will add on to here and continue the chain, and that's what we're going to create. So let's see if they got a better example somewhere. So if we just flip the page, we'll see that there's one here that has sodium acetylide, which is the compound that we're reacting, or something similar to it anyway. And we've got this alkyl bromide. All right, so we've got something similar. So essentially the thing to notice, though, is that these two carbons, part of the triple bond here, are going to attach to this carbon right here where the bromine was. And so this carbon is going to be left over. And so if we look at the other side here, I've got the two carbons from the alkyl bromide. This is where the bromine used to be, but now it's been replaced by this compound here, the rest of the molecule that reacted with it. And so it forms this one long chain overall. So that's what we're looking to do. That's the type of reaction that we're looking to do. So whatever the carbon is that has the bromine or iodine or chlorine attached to it right here, this carbon, we are going to attach and create a new bond between this triple bond and that bond there. So this triple bond remains. There is a new bond that forms between the carbon and the carbon where the bromine or chlorine or iodine was. So to remind us of our reaction, it's similar to what we saw, but it's not exactly the same. So what's going to happen is this carbon right here, this triple bond will remain intact. All the rest of the material will still stay intact, but it's going to form a new bond right here at this carbon. So imagine replacing this chlorine and adding this whole thing over here where the chlorine does. That's what we're going to do. So if I take a look at the reaction further then, here's the two compounds. So I've got the sodium acetylide on one side, and I've got the alkyl halide, and there's my new compound that forms. So essentially what I've done is I've taken the carbon that's here, and it has attacked the carbon right here, like this. It's giving me arrows. I don't want arrows. It's here, let me erase these. All right, let's try this again. So the carbon here is going to form a new bond right here with this carbon. So essentially we're replacing the chlorine. So this is where the chlorine was right here. And what I'm doing is I'm replacing the chlorine with this entire molecule right here attached through this carbon. So there's that carbon of the triple bond. And here's the rest of the molecule that I've got right here. All right, so this is the new compound. So the question then is, now that we've made this compound, is what is the name of this compound? So I got 1, 2, 3, 4, 5, 6. So we're a hexane. And then the question would be, which side do we start from? Also, what is the major functional group? And it's an alkyne. So if I start from here, 1, 2, 3, at the 3 position is the alkyne. If I start from here, 1, 2, 3, the alkyne is at the 3 position. So it doesn't matter where we start this. It's the same on either side. So that means that in the 2 position, 1, 2, 3, 4, 5 position, in the 2 and the 5 position are methyl groups. So we're going to have a 2, 5, dimethyl hex 3-ine. Sorry, I gotta delete some stuff here. Or I can do 2,5-dimethyl 3-hexine. Either of those answers would be sufficient and would give a correct answer. Make sure that there's no spaces in between any of this. So now we go back and we're going to input our answer, 2.5, 2,5 dimethyl I know this would be a wrong answer because I forgot to put the dash here. So once I put the dash in, that's now the correct answer. So if you're missing any dashes, if you're missing any commas, that's incorrect. You got to get it all correct with no spaces here in order for you to get the correct answer. So I hope this helps. And I'll do another video just based off some of the practice ones, but this is from the actual quiz itself.